have colonized towns and cities, countries and continents. They were here long before the arrival of man, and they have always been with him, proudly surviving catastrophes and wars. But who are these silent beings? The elm tree, present since ancient times in Europe, Asia and the Americas, is now showing the danger of its extinction in desperate signs which man attempts to decipher. A terrible disease caused by a tiny organism and transmitted by a small insect has killed in just a short period of time millions and millions of elms that had populated our planet since ancient times. Man, always watching this process, is now fighting to prevent the extinction of the species.
In the United Kingdom, we've lost 40 million elms.
Many of the old trees in Holland have disappeared.
Today we have in Canada in total 803,000 elms. There were millions of elms across Canada.
We know this splendid giant has existed since the earliest times. 7,500 years ago, the inhabitants of northern Europe carved their arrows using only elm wood, and the early Germanic people used the same word for elm and arrow. The first written reference to them can be found in the Iliad, where Homer describes how Achilles, while challenging the river Scamander, grabbed at a large elm tree. The tree was uprooted and fell, holding back the current. In the Mediterranean, the Greeks planted vines and elms next to each other, and the elms acted as a support for the vines. Centuries ago, some North American Indian tribes used elm bark to build their canoes and for the roofs of their homes.
You could say it has always been here. It's been here longer than the states and countries that we know in Europe now.
Clearly, their history is bound to the survival of those people who have populated Europe, Asia, and the Americas since ancient times. An old Greek sage wrote, "Do not deceive yourselves. Right in the heart of an elmwood, each tree has a hidden legendary or magic story to tell. But it shall only tell it to those who understand that in its wood, its roots, its branches, which are always reaching for the skies, and in each of its leaves, the life of a majestic being is unfolding."
I think it's important that we keep our elms. They're part of our culture and part of our landscape.
So what is happening? Why are these trees, whose ancestors colonized the Earth more than 100 million years ago, dying in great numbers across continents like Europe and the Americas? Always watching over it, elm trees have sheltered the Alhambra Palace in Granada for centuries. However, these trees do not want to tell us about historical events. Here, by the legendary Alhambra, a key chapter in these trees' own history of their desperate struggle for survival has been taken place. But all stories should be told from the very beginning. Elms were born and developed by riverbanks. Men, in order to use the land, chopped them down mercilessly. Later on, the elms were very much used for being a great tree that created shadow, becoming an urban tree. This could have been the first serious threat to them, but elms adapted, stoutly resisting the harshest environmental conditions.
The elm tree is a very well-adapted tree to our weather conditions. It can withstand a lot of drought conditions, frost conditions, even pollution. Other trees will die of pollution where elm trees stand.
Elms became part of the urban landscape, to the extent that it was the only tree to be seen on the roads and in the towns and cities of many countries.
In certain Canadian cities, we have very cold winter with a lot of windy days, and also they put a lot of salt on the roads. There is no other tree than the elm tree better fitted for the urban situation.
With their grandeur and their distinct asymmetrical leaves, the elms contribute much to the landscape. The elm's leaves are indicators of the tree's health, due to the presence on them of many animal and plant species, many of which live on the tree without damaging it. However, it is also the leaves that show the first symptoms of danger, the terrible condition known as Dutch elm disease. Leaves lose their strength, they turn yellow and finally fall to the ground, turning the elm into a veritable skeleton. Dutch elm disease appeared in the Netherlands at the end of the First World War and began to spread throughout Europe with devastating effects. Two Dutch scientists, Beyer Schwarz in 1922 and Christina Buisman 10 years later, managed to identify the disease's improbable origin.
Those first periods started to collect elms from all over the world, collected those and tested them for resistance to the disease. I was the first male person to work on these elms. In 1953 I took over from Miss Wendt. We tried to develop as quickly as possible varieties with resistance to the disease.
After a number of hybrids were created, more resistant elm varieties were found, so it was thought that the disease was under control. Unfortunately, however, although a battle had been won, the war had just begun. After a short ceasefire, a new strain of Dutch elm disease broke out strongly at the beginning of the 70s, causing the death of millions of elms, including those thought to be resistant.
In the United Kingdom, we've had Dutch elm disease since probably the end of the 1960s, beginning of the 1970s, so we've suffered from the disease spreading through the country.
We have had the importation of a new disease, which has been imported probably from somewhere in Asia, introduced by man, which is destroying elm trees right across much of Europe and North America.
Therefore, to the disappointment of scientists, the reality questioned the effectiveness of the reproduction programs developed since the disease appeared. Everything was lost after 40 years of struggle. Ancient elms gone forever. But what is the cause of this disaster? It is a tiny fungus that is responsible. Considering its size, it seems impossible that it is able to bring down the colossal elm, and furthermore, in such a short time.
Well, that does seem a terrible thing, that this tiny creature can do so much damage, but then we have to think about, in human diseases, how much sometimes a tiny organism like a virus can cause disease and kill people. So it's the same sort of thing, that sometimes a very insignificant organism can cause a great deal of damage in the world.
If I inoculate a side branch here, it takes 3 to 4 weeks to kill this tree that just died in 3 weeks.
The tree and the fungus have lived together for a long, long time, so they're in a natural balance. We would say this, they are co-evolved. They have evolved together. So they have a normal, healthy balance. But the elm trees of Europe have no experience of this pathogen probably before. So when it comes, it is too aggressive. They don't have any resistance.
In Asia, the tree and the fungus have always lived together in harmony. What has made this microorganism so lethal for elms in the rest of the world? The cross-section of a healthy elm with the clean channels through which the sap runs. An ill tree. The infected sap runs round the tree, reaching the leaves, making them ill and eventually killing them. In a desperate fight for survival, the elm cuts off the vessels where the fungus is moving through, interrupting circulation of sap. But in this way, the branch also dies. The terrible process shows itself in the dark stains that indicate the fungus's devastating passage. The lethal organism moves around inside its giant victim by reproducing itself both sexually and asexually. This double possibility means more capacity to spread and greater virulence. The fungus's appearance and spread is both menacing and spectacular. Leaving all this aside, the big question is how the fungus travels from one tree to another. Its spores cannot travel on the wind, and therefore it has no way of jumping from one tree to another. What then is its vehicle? Among the many types of plants and animals that live in the elm, there are some tiny beetles whose size, depending on the species, varies from 1 to 6 millimeters. A giant grasshopper, 3 centimeters long, gives an idea of the size of this beetle, the deadly carrier. These beetles only reproduce in dead or very weak elms.
Perhaps the elm trees and these beetles that spread Dutch elm disease have been together for millions of years. But the new part of this whole system is this fungus.
Although a number of species of beetle are capable of spreading the disease, some are more skillful than others at this particular task.
Where the fungus has come into contact with the beetles carry the spores of the fungus on their body. So we need to adjust our ideas and try and decide which are the beetles that we need to target and control if we want to control the disease.
These beetles' purpose, like that of all insects, is to reproduce. When the female feels the moment is near, she spreads her wings and takes off.
The fungus has fitted into this relationship with the beetles and the elms and found it very useful because it's the beetles that move the disease, move the fungus around from the diseased trees to the healthy trees.
During the adventure of their trip in search of a dying elm, the beetles stop on the way to rest and feed on a number of occasions, and they do this on healthy elms, normally where the branches fork. In the places where they cannot reproduce, they eat, and this action is fatal for the elm.
Unfortunately, the beetles feed in the tops of the trees, cutting tiny, tiny little wounds. That moment when the beetle is feeding in the tops of the tree is the opportunity for the fungus to get into the healthy trees.
Once the fungus has penetrated the elm, in just a few days it invades its circulatory system, spreading the illness and causing death. However, not all healthy elms are as enticing for hungry beetles. What are the chemical components involved in the selection of elms by these insects? It is known that there are elms that are preferred over others within a single species, but the reason is still unknown. After recovering her energy, the female takes flight again. Her goal is a weak or old elm, where she will begin the fascinating reproductive process, the place she needs to lay her eggs. Finally, the end of the voyage, the weak elm, where she can alight. Begins one of the most curious and unusual displays in nature, the process by which these beetles reproduce. The female soon begins to dig a hole in an appropriate place on the tree's bark. Her goal is to build a gallery where she can lay eggs. At the same time, the beetle emits some volatile compounds known as pheromones. The pheromones impregnate the air with a scent that other beetles can detect, often at proportionally enormous distances. This kind of signal attracts many other beetles towards this particular elm, where they can live and reproduce. Each beetle begins to work on a gallery. The female that we started out with continues her work. While she digs, she creates excrement, which she then expels outwards. The excrement is mixed with new pheromones, in this case for attracting the male, who will fertilize her. When this has occurred, she will be ready to lay eggs in her gallery, excavated encircling the interior of the elm's bark. While she continues her work, she bores small niches in its sides where she lays eggs. The eggs are a translucent white color and between 0.5 millimeter and 1 millimeter in size. The number laid depends on the length of the gallery, with around 16 eggs per centimeter. The female does not pause in her hectic activity, even for a moment, and so the gallery grows longer. At the same time, and between 6 and 9 days after laying, the first eggs start to hatch. The larvae begins life by digging galleries that lie perpendicular to the great mother gallery. The female completes the laying and leaves the gallery. In other cases, she dies, blocking the entrance with her body in order to protect the young from possible predators. In this too, her behavior indicates that everything about her life as an insect is aimed at reproduction. The larvae spend their lifetimes either feeding on the outer layer of the elm where they live, the softest and most nourishing part, or preparing the pupation chamber where they will change into pupae. They eat, excrete, and go on digging these distinctive galleries. Each larva's individual gallery is blocked by a compact plug of sawdust mixed with excrement, which has been built up by the insect itself. This plug will leave the beetle larva perfectly isolated in the chamber, where it will become an adult. Finally, the metamorphosis process begins. Slowly, in the gallery's silent interior, the motionless pupae gradually change into adult insects. Little by little, it is possible to recognize the organs and shapes of the beetle that will take with it a terrible companion present in the nest: the Dutch elm disease fungus.
The next generation of beetles emerges carrying the fungus on their body.
When the beetle finally leaves its chamber and starts its search for another tree, it will carry the fungus with it. Once again, the stopover in the fork of a healthy elm, and with each mouthful that the tiny animal takes, it leaves a deadly poison, the Dutch elm disease fungus. The process will begin again and again, repeating itself as often as beetles approach the dying elm, attracted by the irresistible call of the pheromone.
So of course, once the tree is wilted and died, then beetles will use that tree to breed in, and so the cycle is completed.
The fatal combination is the cause of the death of millions and millions of elms. Don't deceive yourselves, said the old Greek sage. Each elm has a story to tell. Granada and its magical Alhambra. For centuries it has been surrounded by one of Europe's largest elm groves, a symbolic representation of the elms that are threatened by almost certain death. These trees are lucky because some men know how to listen to what the trees have to say. The elms of Granada are the setting for a great struggle of man against the Dutch elm disease fungus and its winged carriers. In this struggle, the experts' main resource is observation. They watch carefully, elm by elm, for any sign of the disease. However, every possible measure amounts to little in the face of the invader.
Yes, people are very important. Both in terms of having an interest and giving support to the research programs, and in terms of giving information on where they have seen a disease problem.
You need to use the eyes of people, and they can help you fight the disease.
When any anomaly is observed in so much as a twig, it is immediately eliminated. The idea is to save the life of an elm as soon as the disease has already appeared. On some occasions, prevention arrives too late. Then, when the infection could not be eliminated in time, a cut was made in the tree's bark to halt the advance of the fungus carrying superficial sap towards the roots. Another measure to fight the disease was to attack the enemy by injecting fungicides. The injection was made under pressure directly into the tree's main roots.
And in some cases, people were using injection by fungicides, which were effective to a certain degree for prevention, but not for curing trees. This also is reduced in the eastern part of Canada, but I think in the west they have another program still going on.
However, a healthy elm located near another ill one can become infected through the connection between their roots. In that case, trenches are dug to eliminate possible contact. Another measure to do away with the harmful insects is to use insecticides, applied by means of cannon fired towards the elm's crowns, where the beetles stop to eat. They prevent the appearance of the fungus.
Now, we have found out spraying against the beetle is very difficult in the cities because of insecticides. That means the environmental effect of the insecticides, not only to the people, but also to the animals and other organisms that are living there.
That was very expensive, and we realized we had to understand much more about how the fungus and how the beetles and the elms fit together in the process, understand more about that so we could learn when to apply treatment and when not to apply treatment.
Negative consequences for the environment caused by spraying the trees has led to a search for less aggressive insecticides and to looking for new ways of attacking the beetle that carries the fungus in order to halt its reproduction. When diseased elms are located, they are quickly pruned and the wood destroyed before the next generation of these prolific insects appears. In just a single generation, a large elm such as this one can produce up to 500,000 beetles. In contrast, in just 3 weeks, our giant's leafy crown may become a pile of chopped wood. Another ingenious system tried out to dispose of the beetle has been to place traps. A section of elm trunk, scented with the pheromones that attract the beetles during reproduction, is one of them. Naturally, the trunk is totally covered with insecticide. In this merciless war against Dutch elm disease, the help of a powerful ally has been also sought. In the 90s, tests began on fighting the beetle through the use of one of its natural enemies, the wasp. A diet of water, pollen and honey gives our soldier a longer life. The wasp's lifespan is normally about 60 days. But with careful feeding, it can be lengthened by another 15. Observing the behavior of this mortal enemy of the beetle, we know that these extra days can be of vital importance. The wasp has a specialized sensory system that allows it to locate its prey very quickly. These are the beetle larvae, comfortably accommodated in their chamber inside the elm. Using its ovipositor, the wasp begins to drill into the tree right above the place where the larva is resting, where it'll be surprised by the attack. The hardness of the wood is no obstacle. Sooner or later, the insect will drill through the bark. When the goal has been achieved, the insect inserts its sting and lays an egg right on the beetle larva. The effect is surprising. The larva is anesthetized, and all its activities aimed at transformation into an adult are therefore paralyzed. After a few days, the Hymenoptera's egg hatches and begins to feed on the paralyzed beetle's larva, which takes around 5 or 6 days. In this way, nature achieves a new feat. In the place where a beetle should have come into being, a wasp arises, emerging triumphant after destroying it. The extraordinary speed with which wasps mate also helps the cause. The males, who are born before the females, quickly undertake a struggle against other males for the control of territory, in this case the surface of the tree bark, and then anxiously await the appearance of the females. During this apprehensive wait, there will still be time for a fight against another pretender. During this time, we can observe slight differences in size between the two insects. This depends on the size of the beetle larva on which each one has fed. The first signal announcing the female's appearance increases impatience even further. The male's anxiety is so great that his partners arising to the surface must be seen twice to really appreciate it. Each time this scene takes place, a beetle will die, and so a small contribution is made towards man's efforts to save these elms, a symbol of the ancestral link between man and nature. Other species of wasp also contribute to saving these elms. When the wasp is smaller than the beetle, then it introduces itself to the gallery entrance and lays its eggs directly over the beetles. The slender snake-like body of other species of wasp allows them to dig into and advance to the larva's excrement. Then the insect lays the egg on the larva, in this case without the effort of drilling into the bark. However, how many regiments of wasps would be needed to eradicate the disease-carrying beetle? Since the disease has appeared, man has used his skills and ingenuity to fight it. The question is, what future does the elm have if it is not helped at all times?
In France, the goal was to find methods for conservation. In fact, there are two types of methods. One is to preserve specimens away from their natural setting, in a kind of Noah's Ark, putting them in a box with a special compound and keeping them cool for centuries. The other solution is to leave the population in place and allow it to evolve and adapt so that it can look after itself in the years to come.
The most helpful way forward seems to be genetic improvement. Research groups are trying to use this method to fight the disease, locating resistant elms. Elms like these, which have been able to fight off the disease-carrying beetle's attack thanks to a secretion, a defense mechanism that stops the insect entering the elm and even manages to kill it. This resistant elm can be propagated using parts of it that, properly planted in suitable surroundings, make it possible for the elm to multiply. In this way, numerous replicas are created, each one genetically equal to the original elm with the same characteristics.
If you plant seedlings, then each seedling is different. But if you plant a clone, you can predict more or less how it will behave.
Year after year, researchers have been seeking resistant elms in order to propagate them. After a period of time of between 2 and 3 years, once they have grown and been moved into the field, the fungus is artificially introduced. What happens then indicates whether the elm is resistant to the disease or not. A quicker form of experimentation is putting cell cultures from an elm into contact with the fungus. The leaf is cut under sterile conditions and placed in appropriate culture media. Little by little, the tissues swell and begin to split into undifferentiated cell masses, known as calluses, whose growth is monitored. The cultures obtained can be used in different types of test in order to assess their resistance. To achieve new tree shoots, the calluses that have been obtained in vitro are transferred to another receptacle containing substances to stimulate their growth. We soon see how the calluses turn into roots and stems with leaves. These miniature trees are identical copies of the elm from which the leaves were taken. Through asexual propagation, it is possible to keep them as resistant as the original. Weeks later, these tiny tree shoots are extracted from the sterile conditions in which they grew and are moved to niches with intermediate conditions, which is the step before they are put out into the field. One day, these tiny plants will become one of these great trees. Thanks to classic genetic improvement, there are new elm species that would have taken nature herself hundreds of thousands of years to obtain.
We have released some 7 varieties in Holland, which are more or less resistant to the disease. And we are also getting some resistant material from North America, and they are being planted, and they are also planted in other countries. This one was originally planted as a small one, a 1-year-old or 2-year-old plant. And now it has been dug out and transplanted here. Grandparents were one tree from the Himalayas, and the other was Exeter, England, and those were again crossed and again crossed. And so this is the 3rd generation of breeding.
Elms that have been created by crossing an Asian tree with a European one. Strong, healthy elms planted throughout Europe and the Americas.
The Asian elms are what we call tolerant. They can be infected with the fungus, but it doesn't cause us any symptoms.
If the Asian elm and the fungus live in harmony, could the key to beating the disease definitively be here?
There are other elms around, some of them in Asia, which have useful genes in them, which we hope to be able to use to recombine with the native elms.
When the first researchers collected elms from around the world to create crossbreeds, they combined Asian elms with others. But the disease continues. In recent years, genetic modification has added to classic genetic improvement.
A traditionally bred tree may have very many changes, and you must screen many thousands of progeny before you get the one you want. With genetic modification, this process is much faster and in many ways more efficient.
Genetic modification consists of creating resistant transgenic elms using the introduction of new genes into their DNA.
In our lab, we have produced the world's first genetically modified elms, and we've also produced genes which have antifungal properties inserted into the tree genome. Some of the work is to introduce reporter genes into trees so that we can characterize them very quickly. And one of the genes we're using is called GUS, which enables the tree to be stained blue.
But the consequences that could result from altering the elm's genome are still unknown.
Some people feel that to alter a tree's genome is somehow unnatural, but the organisms we use to do this have been doing exactly the same thing for millions of years.
As happens with humans, vaccines can immunize the elm against the disease.
First, treated the tree, we vaccinated it with a non-virulent strain. And then we inoculated it with a virulent strain. And if your vaccine here is working, you protect the tree. If it is not working, the tree will die. It was sick, it showed some symptoms, but it recovered, like you recover from a flu.
However, it would be difficult and expensive to carry out vaccination campaigns. There are also microorganisms which could be of great help.
We ourselves are specializing with some of our colleagues in looking to use viruses as a means of controlling this fungus.
Now we're thinking much more about how the fungus is changing, whether we can use viruses to control the fungus, viruses that will attack the fungus and cause a disease in the fungus as well.
But our enemy does not give up easily. Granada's Alhambra. Despite all the effort and perseverance to avoid their loss, the elms that surround it have died. Will this be the fate that lies in wait for all the planet's elms? The experts have tested the fungus's capacity to adapt, and the results are alarming.
The fungus is changing. It's not just invading and spreading and killing millions of elms, which it is doing, but also it is evolving very rapidly to its new environment.
After all this hard work and dedication, will we in the end be able to let the elms survive in the face of this epidemic, one that seems to be unstoppable? Or will we have to say goodbye to this majestic tree forever?
I think you've got to look at other illnesses, for example, like AIDS or cancer. It's often not easy to find a cure. It takes many years and you have to gather a lot of information together.
Trees are like humans. They have a juvenile state, they have a middle-aged state, and they have an old state. Only the tree, an elm tree, can grow up to an age of 380 years. So I wish we would know how the tree manages that, so humans could be maybe also in good health 380 years old.
We hope one day we will be able to restore the elm to its habitat.
And there is a future for the elm. If we keep working on it, we can begin to bring elms back into the countryside, into our cities.
Elms should be here to help man build a world where he can keep on living.
I am optimistic. Elms are a key tree that people know about and want to make sure is going to be there for their children.
In the past, man changed species' natural course. Now and in the future, it is up to him to give back to these giants with mud feet the generosity they have shown to him in past times.